So, okay, so this is what we're looking for you to do. Okay? So for the one section on triangles, determine whether the triangle ABC is scalene, isosceles, or equilateral. Explain. All right, so point C is located here at 1, -3. All right, at 1, -3. All right. So now when you do this tonight, it's due tomorrow at 3 o'clock. All right, it's due tomorrow. Yeah, it's due tomorrow at 3 o'clock. All right. All I need to see is the result of your side lengths. I don't need to see your work. If you want to show the work, fine. But I just need to see the side lengths. So whether you do it in the diagram itself or on the side, I would expect to see how AC, all right, is the square root of 8. Remember, you don't have to simplify everything. All right, BC is going over 2 and up 4. All right, so BC is the square root of 20. 1, 2, 1, 2, 3, 4, so it's the same thing. So AB is the square root of 20. All right, so that's all I would expect to see for work. Anybody have a question at this point about where those numbers came from? It's not 120, it's the square root. They're both the square root of 20. Where did it come from? Okay. So big, does it matter which side I do? Okay. So basically, you're either going to use distance formula or Pythagorean theorem. So you're going to figure out how far you're going across and how far up. So that's 2, and that's 4. So 2 squared is 4, 4 squared is 16. So it's the square root of, I'll draw it out. It's the square root of 2 squared plus 4 squared. 2 squared is 4, 4 squared is 16. That's the square root of 20. Okay. So how you do it is up to you. If you want to use distance formula or Pythagorean theorem, it doesn't matter to me. You're doing the same thing. Whatever you find is best for you. Your quiz on this, yours will be next Monday. We'll flip-flop. So this week, you took it on Friday, they took it on Monday. Next week, they'll take it on Friday and you'll take it on Monday. And it'll be short. I don't mean in terms of height, I just mean. Oh. Okay. So you have 2 sides that are equal in length. So it's isosceles. So it is isosceles. What you then have to go back and do is see if it is a right acute or obtuse triangle. All right, you then have to go back and see if it is a right obtuse or acute triangle. To do that, we're going to use the Pythagorean converse Pythagorean. All right, so we are going to do square root of 8 squared plus square root of 20 squared versus the square root of 20 squared. All right. When I square the square root of 8, they cancel out. And I get that expression, 8 plus 20 versus 20. 8 plus 8 is, of course, 28. 28 is greater than 20. Whenever a squared plus b squared is greater than c squared, we have an acute triangle. So So my final answer is either acute isosceles or isosceles acute triangle. All right. Okay. Pretty good? All right. Couple more. 3 more, actually. Okay. So number 4. All right. Number 4. Determine whether the parallelogram is a rhombus, rectangle, square, or none. Explain. All right. So I got -3, -1, -3, 2, 1, 1, and 1, -2. All right. So I'm going to quickly sketch that out here on the side. So this is number 4. So -3, -1 down there. -3, 2 up there. 1, 1 there. And 1, -2 down here. All right. I can then connect them. Okay. This is a vertical line, ladies and gentlemen. Its slope is undefined. This is also a vertical line. Its slope is undefined. All right. Good. Everybody recalls that from last year, vertical line on the phone? Okay, because it's over 0. All right. Now, from -3, 2 to 1, 1. That's that line there. Okay, from -3, 2 to 1, 1. From -3 over to 1 is 4. From 2 down to 1 is 1. So the slope of that is -1, 4. At that point, ladies and gentlemen, I can eliminate rectangle and square. At that point, I can eliminate rectangle and square because they're not negative reciprocals. All right, but it is a parallelogram, so that one's also -1/4. Up to you whether you feel the need to do that or not. Now, to determine if it's a rhombus, I need to do diagonal. All right, that diagonal is going from -3, -1, all the way to 1, +1. So it's going up 2 and over 4, so that has a slope of 1/2. All right, I then need to do the other diagonal, which is going from -3, 2 over to 1, -2. All right, it's going down 4 and over 4. So that has a slope of -1. Great numbers, but are they negative reciprocals of each other? No, so it can't be a rhombus. All right, so therefore it is simply a parallelogram. If you want to use distance formula, you certainly can. That's up to you. Okay. Now, if you want to do it without a diagram, that's okay. If you feel you can do that, you look at number 7. The sides are consecutive vertices. So all you're going to do is look at each pair, all right, that are next to each other. So -3 up to 5 is going 8. From -6 to 0 is going over 6. So that has a slope of 4/3. 0, 5 to 10, 5. Goes up 0 and over 10, so that has a slope of 0. All right, that's a horizontal line. From 10, 5 to 4, -3 is going over 6. All right, and up 8, so that is also 4/3. Please don't forget, ladies and gentlemen, if you're going to do it without a diagram, you also need to do the first with the last. All right? So you do first, second, second, third, third, fourth, fourth, first. And that also has a slope of 0. 0 and 4/3 are great numbers, but they're not negative reciprocals. So again, we've eliminated rectangle and square. So now we have to do the diagonals. The diagonals are alternating vertices. So I got to do -6, -3 to 10, 5. Everybody okay with that? That's going over 8. All right. And that's going over 16 and up 8. So that has a slope of 1/2. And then I got to do the second with the 4. So 5 to -3, all right, is going down 8. 0 to 4 is going over 4, so that's -2. Are they negative reciprocals of each other? Yes. So number 7, ladies and gentlemen, is a rhombus. If you want to use distance formula instead, feel free. It's up to you, whatever's better for you. All right. So basically, we'll talk to you about this later in the week, but when you take the quiz, there'll be a box where you enter either the distances of the slopes. So you show your work that way. All right. Now, the next section, what is the most precise classification of the quadrilateral formed by connecting in order the midpoints of each figure below? For this, it takes so much time, you are certainly allowed to memorize. So it's up to you if this is easier for you. All right. So let me get rid of some stuff. All right. Get rid of this, get rid of that, get rid of that. Get rid of that. Okay. So, like this, move this over here so it's easier to see. Okay, let's get rid of the labels here. And get rid of the labels here. Get rid of the labels down here. Okay, so if you just want to memorize this, it's fine. It's not going to matter to me. All right, so I'm going to do this, and we're ready to go. Windows P, duplicate, and now we can all see my screen, which we can. All right. So that, ladies and gentlemen, is a parallelogram. And those are the midpoints connected. All right? Now, so basically, if I connect the midpoints of a parallelogram, I have to figure whose opposite sides are congruent. All right? Now, if I measure their lengths, though, they're not all congruent, which gets rid of the rhombus. And if I measure this angle, I'll realize it's not a right angle. It's two. So therefore, if I connect the midpoints of a parallelogram, what kind of figure do I create? Another what? Parallelogram. Okay? So I create another parallelogram. Okay? Everybody good with that? Okay. So now I'm going to come over here, down here, this one. I'm going to measure these lengths. Now they're all the same. So that's the rhombus. You with me? Okay? So now, if I measure that angle, I know it's a parallelogram, but that angle is a right angle. A parallelogram with right angles is, of course, what? A rectangle. So if we connect the midpoints of a rhombus, we have a rectangle. If I come up here and I connect the midpoints of the rectangle, they're all the same. So they're inverses of each other. Midpoints of a rhombus create a rectangle. Midpoints of a rectangle create a rhombus. All right? Square we're not going to do. A square gives you another square. Because a square is both a what? Rectangle and rhombus. So the inverses are going to give us a rectangle and a rhombus. Okay? All right, we come down and we do a kite. Okay, we come down, this is a kite down here. I measure the opposite sides. They should be the same, which they are. So I have a parallelogram. I measure an angle. And I have a 90-degree angle. Midpoints of a kite also give us a rectangle. So both the kite and the rhombus give us a rectangle. And then the last one we did together is an isosceles trapezoid. All right, so if I connect those, they should be all the same. So that, of course, is the bus to rhomb, the rhombus. However, if I measure an angle, you hopefully recognize that it's not a right angle. All right? So rather than make you connect the midpoints and do all that, we'll do that enough with mid-segment tomorrow. All right, so tomorrow's lesson will be the last thing that involves the quiz later in the week. All right, and then Wednesday we will do, Wednesday we will do, we'll begin the next chapter, which is similarity. Everybody good with all those? Okay, so that brings us back to practice K. All right. So that means if you memorize those ideas, if you look at number 8 is a parallelogram. So if I connect the midpoints, all I would get is another what? Parallelogram. Number 9 is a kite. So if I connected that, I'd have myself another rectangle. All right, and I'd be done. So that's all you got to do with those tonight for homework, okay? All right, now the back. All right. Graph and label each triangle with the vertices. Determine whether each triangle is scalene, isosceles, or equilateral. Then tell whether each triangle is a right triangle. So -3, -2. 3, -2. 0, 3. All right. Ladies and gentlemen, a horizontal line, all you have to do is count. 1, 2, 3, 4, 5, 6. So that horizontal line has a length of 6. When I'm doing each of these signs, hopefully you recognize that's a line of symmetry. So they're going to be the same. I'm going down 1, 2, 3, 4, 5, and over 1, 2, 3. All right. 5 squared is 25, 3 squared is 9, gives me the square root of 34. And that's also the square root of 34. All right, so that, ladies and gentlemen, is, of course, isosceles. Then when I compare them, 34 is a little less than 6. So I'm going to compare the square root of 34 squared with the square root of 34 squared versus 6 squared. When I square root, they cancel out, so these would both give me 34. 34 plus 34 is 68. 6 squared is 36. 68 is greater than 36, making that triangle. So it would be an acute isosceles triangle. All right? Any questions about any part of that? Okay, those of you at home, feel free to go unless you want to stay and ask questions. Otherwise, you're good to go. Finish the practice sheet. We're going to go over in a second. Hold on, don't go. We got to go over what you need to do in practice sheet. Don't go. Let me leave. All right, so let's go over practice G really quick to make sure you don't waste your time and you do the assignment correctly. All right, so if we're looking at this, and now we're looking at G, due tomorrow at 3 o'clock. Determine whether triangle XYZ is scalene, isosceles, or equilateral. Then determine if it's acute, right, or obtuse. Okay, then determine if it's acute, right, or obtuse as well. So you're doing both. Now, if you take a quick look at numbers 1 and 3, what do you notice about 1 and 3? They are exactly the same. You do not need to do 1 or 3. You just have to do one. All right, 5, 6, 7, 8 are all connecting midpoints, so you don't need to show any work for those if you do not want to. You just have memorized where they are. You're good to go. All right, 9 and 10, you're just regurgitating some notes, so that should be fine now. Okay, 11 and 12, you're looking at a trapezoid. All right, you need to determine if it's an isosceles trapezoid or not. All right. They already tell you it's a trapezoid. These sides are parallel. So you don't need to work with those. You just need to look at these. Because if it's isosceles, they would have to be the same length. All right, so you just use the distance formula to find them the same lengths. All right, part number 12 for that is the quadrilateral formed by connecting the midpoints of a trapezoid, parallelogram, rhombus, rectangle, or square. Explained. If you just want to give slopes, you can do it that way if you'd like. Okay. 13 through 17 is where most of your work is going to be. Determine the most precise name for each quadrilateral. This is what I would expect to see. M stands for slope, so slope of the sides, slope of the diagonals, type of quadrilateral. If you want to use distance formula instead, feel free to just show that. All right. So determine the most precise name for each quadrilateral and find its area. You do not need to find its area. We'll deal with that later in the year when we're in chapter 8. All right. So find the slope of the sides, the slope of the diagonals, and then tell me what quadrilateral it is. Just make a little chart if you want. Again, I don't need to see where you got from it. If you want to use distance formula, you can. The last two, 18 and 19, determine whether the triangles are congruent. Explain. Ladies and gentlemen, 3 letters for you. Side, side, side. So just use distance formula to find the side lengths of each. If they're the same, then you have a congruent triangle. If not, then you don't. Okay? That's all you got to do with that. And then that's due tomorrow at 3 o'clock. There is a regular lesson tomorrow, but that won't be on the homework. All right, now those of you at home, I accidentally did the quiz review instead of the quiz, and the quiz isn't showing up for me as you like. Oh boy. All right, give me 1 second, Marissa. Everybody else, you are free to go if you'd like. Enjoy your day. All right. If you want to stay on and ask questions, that's fine. If not, be safe. Don't slip on the ice. Now I got to see what's going on here. So I'm going to stop recording. Yes, I'm going to stop showing you what's on my screen. I've done that. All right, so we got this. So now I got to see what's going on. Ease at home taking it. 1D. Nora. You may have a second. I just want to take her. I mean, she responds to it. You know. Marissa, are you there? Is you there?
Yeah, wait,
Okay, which one do you use? Do you because I have you in two accounts there. I have a Google account and a Southern Regional. And I think what I did is I assigned it. Don't. It's not. I just want to know which one you use moving forward, so I can delete the one that you don't use, so this doesn't happen again.
it should be on the SRSD one.
Okay, so I have the SRSD one, but I also have Marissa Olson 2000 at gmail.com.
Yeah, that's my Gmail. So
Okay, so
probably
you
just get
don't
rid of
use
that.
that one. You use the SRSD.org one.
Yeah.
Okay, so I'm trying to do this. Hold on. Okay, so basically, do you want to take it now? I don't know what you have second period. Do you want to take it now or do you want to take it later in the day?
Um, I have history. I don't know if I should like,
That's what I mean. So do you want me to just open it up at 2:12 today at the end of school?
yes, please. I'm
Okay,
sorry.
I'll open it up. It's okay. And then we just have to delete the one that doesn't, you know what I mean, have you that
Yeah.
you use. Um, so we'll go that way. All right. So it'll be
Okay.
open at 2:12.
Okay, thank you.
You're welcome.
Bye.
Bye. All right, Sister Nora, come on up. Okay, so this is what we got. Nope. Nope. Of course not. Back to 1A. Okay. So what I got is, did you use this full time?
I think so, yeah.
Okay.
My computer was
I know.
like,
I got the emails. I read them later, unfortunately. So what I can do is after school today, I'll give you the remit. Like I just want to make sure is this accurate?
yeah, that's fine.
Okay. So when you get home, what I'll do is it'll be open up for a few more minutes, so you can go back and check it out.
Okay.
Okay.
Thank you.
Yeah. Next time, do yourself a favor. No, don't open it at all.
Okay.
Just email me and say, hey, my internet, because I get it. My internet is wacky. Can I just take it later in the day and we'll just do it later in the day? You're welcome. Silence!
I was wondering when I could make the test up.
Oh my goodness! Tomorrow 2:12, okay?
Yeah, that sounds good.
All right, I'll open it up tomorrow 2:12.
Okay, thank you.
You're welcome.
Have a nice night or
You
day.
too. All right. Let me take care of yours first. So this is now done. So, I mean,